Third law of motions. Every action has an equal and opposite reactions. We take one last example to understand something very interesting about third law. What happens when gun is fired? You're right, it exerts the forward force on the bullet, and the bullet exerts an equal and opposite reaction force on the gun. And this exists in recoil of the gun, a perfect example of Newton's third law. But hold on, if the force exerted by the gun on the bullet is the same as the force exerted by the bullet on the gun, then why doesn't gun recoil with the same acceleration as the bullet? The gun recoils, yes, but it doesn't recoil as the same acceleration at the bullet, right? Same magnitude of forces but different accelerations. Why do you think this happened? Okay, so if your concept of the second law of motion was clear, you would really be surprised with this. The second law of motion says that the first is the product of the object mass and accelerations, or the accelerations of the object is equal to the first over its mass. What does this tell us? Yes, if the mass more than the accelerations will be less. In this example, the mass of the gun is much more than that of the bullet, hence the acceleration of the rifle is lesser than of the bullet. Newton's law of accelerations. Newton's second law states that the direction of net force and accelerations are the same, and both are directly related, while acceleration and mass are inversely related. Newton's law of interactions. Newton's third law describes something else that happens when one object exerts a force on another object. According to Newton's third law of motions, force always act in equal but opposite pairs.